Hey blackpenredpen, can you make a solution video on this problem? This is AIME 2012 problem number 14. Though it has solutions online, I couldn't understand them. Hope you read this. Thank you. Okay, let's have a look. So we have a functional equation. Given that f of x times f of 2x squared is equal to f of 2x cubed plus x. That's true for all x. And we know f of 0 is equal to 1. F of 2 plus f of 3 is equal to 125. And the goal is to find out the value for f of 5. So this is how I did it. Firstly, I think the biggest hint is this right here. 2x cubed plus x, where we can factor on x. So this equation is the same as f of x times f of 2x squared, and that is equal to f of factoring on x. We have 2x squared plus 1, like this. Now have a look. This inside times that inside, it's very similar to this inside because we have the x and also the 2x squared from here and here. It's just that we have that plus 1 right here in that parentheses. Okay, what do we do next though? Well, usually when we are dealing with a functional equation, we want to start with some guess and hope for the best. And of course, you want to start with a good guess. I don't think you want to use log function because you have a log function times a log function, you cannot multiply the inside. Well, you don't want to use exponential functions either because exponential function times exponential function, you will have to add the exponents, right? You have to add the inside. I want to multiply the inside. So I will start with a power function. So right here, this is the general form that I'm going to try. Let's say we have f of x. Let's say this is equal to some power. I don't know what power is yet, so I'll just put on n. So right here, let's say we have the input x. So that's my general form of the function, okay? And if I have this, f of x will be what? It's just this part, parentheses to the nth power, and then we have the x right here. So this is the input, I'll put it here. And then this right here, we multiply by this input, which is 2x squared, and then nth power. And that will be equal to this thing. And you see, I will just put it here, x, 2x squared plus 1, like that. And as you can see, when we have a power function times a power function, we really just multiply the inside. So the left-hand side becomes like this, and that will be set it as that. And right now we can just multiply the x and that, but of course this is not correct. So we have to make more change. Let's take a look at the next information. We have f of 0 is equal to 1. I don't want to put a plus 1 on the outside because otherwise I cannot multiply the insides like this, right? So let me try plus 1 right here. So that means when we have f of x, we will have x plus 1 to the nth power. And this will be 2x squared and then plus 1 to the nth power. This is right here, but I still have to put on the plus 1 because we have that right here. Okay. Right here, let me just try to see if this is actually going to work. If it is working, then we have the function and we can just continue. If not, we will have to make more changes. Okay, so let's see. Multiplied inside, the first one is just going to be x plus 1. And then the second one is 2x squared plus 1. And that will be equal to this, right? So it's x times 2x squared plus 1 and then plus 1. I don't want to distribute this because if you just focus on the inside, I can take the x times the first whole thing here. So I get x parentheses 2x squared plus 1. That is really good, right? And then 1 times 1 would be a plus 1. That is really good. However, once we do the x times the parentheses right here, I will have to go with the 1 multiplied by this, which is plus 2x squared. And then we have that plus 1. Oh my goodness. Almost, right? Almost. You see that? We have that 2x squared. So what do we do? Well, right here we may have to make more changes, and I think I'm just going to work with the power here. Since I have an unknown power already, so I'm going to just kind of guess a power and see if I was lucky enough or not. So what I'm going to do next is I will try x to the second power. So if I make that change, f of x will be this thing, but the x will be to the second power. And this thing right here will also be to the second power. And this thing right here will also be to the second power. Okay, and then this right here, we will just have to change to x squared. Good. But this right here will become this thing squared, which is, let me just rewrite everything again. So we have x squared plus 1 times this thing, which is, I'm just going to write it as, let's expand it. So it's 4x to the 4th power and then plus 1. And then to the nth power. And let's make it equal to this. And right here, I will distribute the power. So it's x squared times this thing, which is 2x squared plus 1 and then squared and then plus 1 to the nth power. And let's see, if I take x squared times this thing, right, this whole parentheses, I get x squared times 4x squared, 4x to the 4th power plus 1. Okay. That is kind of similar to this, because if you expand this, you have x squared, and the first term of this expansion is precisely 4x to the 4th power. Good. And the last term right here is the plus 1. Good. But in the middle here, what do we have? In the middle here, we have 2 times this and that, so we will have to have the plus 4x squared. So far, they are not the same, but don't worry, because once we take this, multiply with that, we move to the 1, and then we multiply with this. How does that look? It looks really good, because this times that is plus 4x to the 4th power, and then lastly, we have that plus 1. Nth power, and then this thing is from here, and then we have the plus 1 raised to the nth power. Now, ladies and gentlemen, you see that if you distribute, this thing is 4x to the 6th power and then plus 4x to the 4th power. Yes, and then plus x squared and then plus 1. That's exactly what we have right here. So this and that is 4x to the 6th power, and we can add the then plus x squared and then plus 1. And then both of them are to the nth power. Okay, so this right here is the form that we know for the function. But we still don't know what n is though. That's where we have to use this information. So let's go ahead and continue. So now we know this is the form of our function. We still don't know what n is yet though, but it's okay. Let's see f of 2. This is just going to be 2 squared plus 1, which is 5, and then raised to the nth power. And then similarly, f of 3. 3 squared plus 1 is 10, and then raised to the nth power. So when we have this plus that is equal to 125, that means 5 to the n plus 10 to the n is equal to 125. And for this equation, it's not so bad, because if n is equal to 2, we get 100, and that happens to be 5 to the 2nd power, which is 125. It makes that perfectly. So n is equal to 2. So all that tells us our function is just x squared plus 1 squared. Now we just have to figure out what f of 5 is. So that will be 5 squared plus 1 squared, which will be 26 squared, and work that out, 676. That will do it.